what I would like to provide in this talk is to explain the design process conducted in the Hexa-X-II project for establishing a holistic perspective on this 6G end-to-end system, and with the goal to target this 6G key performance, but also the key value objectives that are highlighted in Hexa-X-II, that are environmental, social, and economical sustainability. So in this talk, I will start by explaining the motivation to 6G system, then providing a roadmap for the design of the system, and including the design principles, the requirements, the blueprint, and then go through a structured design process. Starting at looking at the motivation to a 6G end-to-end system, we start by exploring the evolution from 5G to 6G. And as one of the lessons we learned from the migration from 4G to 5G was that we have to limit the number of deployment options. And in 6G, we should focus on 6G standalone from the beginning. And for this, the core network will be an enhancement of the 5G core, so that both 5G radio access and 6G radio access can connect to the same core. And new or enhanced components of this core are gradually added in order to support the 6G device and 6G radio. Then, looking at the 6G radio access network more in detail, it will be indeed gradually deployed with coexistence with 5G standalone system. And for that, from the first release, we will have this multi-rad spectrum sharing implemented in 6G to allow a dynamic allocation of the spectrum resource between 5G and 6G. This will allow wide area coverage, and then we will have also a new spectrum, centimeter spectrum, to provide some boost in performance, and also some higher band spectrum to provide extreme performance. Then we also consider that in Hexa-X-II, 6G will be the platform that will provide a wide range of services, not only those services related to communication, to vertical end user or application, but really enabling value of new services such as AI service, compute offloading service, and so on. So on this 6G platform, the network will expose a diverse set of application programming interface that can be extended over the time. And on the same time, this platform will allow interaction with application to understand and integrate insight from the external environment to create a more adaptive system that will allow to meet the need of a user and society. Then we have defined the 6G design principle, and we have defined indeed 10 design principles. They are shown on this figure, and they relate to intelligence, automation, flexibility, trustworthiness, efficiency, and also aspects related to environmental sustainability. And indeed, those principles can crystallize in top 3 design principles that are put in red on this figure for achieving the key value targeted in Hexa-X-II that are environmental, social, and economic sustainability. Moving forward, then we set a preliminary set of 6G system requirements that we have identified. And indeed, we started from the requirement from the 6G use case to identify a capability of the system in terms of what it should do. And for example, it's about providing extreme connectivity, compute as a service, positioning and sensing, and so on. But also this initial set of requirements have been completed by some operational requirements that the operator need to provide in order to be able to operate efficiently the network, such as seamless orchestration across the compute continuum or 6G capability exposure, and so on. Of course, these are only initial set of requirements, and we are going to refine them in the next iteration of our work for the 6G design. So now moving to this end-to-end design, before starting to describe the design, I just want to state some definition of terms that we use in Hexa-X-II. So I've already talked about this 6G platform as the external view of a set of 6G capabilities. And then the end-to-end system, it's the technical realization of this 6G platform. And it includes all the technology enabler and their interaction. And then we've got this 6G blueprint that is a reference architecture that meets this end-to-end system needs with respect to hardware, software, and application. And in Hexa-X-II, we've got some 6G enabler, and an enabler for us is any technical assets that make it possible to realize or enhance our 6G capabilities. So now, based on the design principle and the system requirements, we provided the first foundation of this 6G blueprint that allow us to have a framework for integrating all the new functionality and technologies that come from a selection of enablers that are ongoing inside Hexa-X-II, but also covering innovation and enabler coming from other SNS, European SNS projects related to 6G. And so this is a first foundation, so it will evolve in the next iteration until the end of the project. But currently, we've got 4 main layers. So on the top, you've got this traditional application layer from third party. And then we have this network-centric application layer, whose role is to enable a full ecosystem of application to interact with the underlying network, 6G network, via simplified API for leveraging, for example, QoS, sensing service, or localization service, computer service, and so on. And it also provides some means to have a controllable exposure of those 6G capabilities toward application. And since 6G service will be more global, so not only providing communication services, but a more composition of a diverse set of services, this layer will provide some means for aggregation of those services that can even come from different 6G service providers. And then we've got this network function layer with the RAM, the core, and important this new beyond communication capabilities that will come with 6G, integrating, for example, sensing, AI, or compute as a service. And finally, we've got this infrastructure layer that encompasses not only the end-to-end, the device and the end-to-end network infrastructure, but also this compute continuum from the cloud to the extreme edge integrated in the end device, and as an essential feature of this 6G system. And finally, completing those 4 layers, there are these pervasive functionality. So they are so cool because they span all the layer and also inside each layer. And also it's worth emphasizing that all those diverse functionality interact with each other. And there are, for example, this data collection framework to cope with distributed application and service in cloud environment. This AI framework that will support distributed AI and AI as a service aspect related to security and privacy in order to address 6G specific threat, and also management and orchestration functionality that will rely extensively on this intent-based management approach and AI or machine learning. for automation, for energy consumption reduction, and also to provide appropriate level of program scalability and so on. Also worth to mention that this global blueprint is not enough to capture all the aspects of the holistic system. So we will have some dedicated view to complete this overall system blueprint, and I will show you later a first view focusing on management and orchestration. But now maybe starting to think about how we could move from a set of 6G enabler toward a 6G system design, looking at how we can select and map onto this blueprint all the enablers that are developed around 6G technology. Then we have to study how all those components can be systemized and integrated inside this end-to-end system. And then also it means that we have to assess how they contribute to this system related to performance and how they can impact also and relate to each other. So for that purpose, it means that since we will have, for example, in Hexa-X-II, more than 100 enabler, of course, we need to have a system design process. And in Hexa-X-II, we provide iterative system design because we will have more and more refinement, taking into account more and more KPI and KVI, and also more and more enabler. And so basically, if we consider this iterative system process, it will be composed of two subsystems. The first one is called a KPI and KVI based iterative sub-process. And we start indeed from the use case to the target KPI and KVIs, and then we elaborate the system design to consider what are the functionality and what are the components to integrate for fitting the need of those use cases. And then we evaluate the design through system-level POC, emulation-based approach, in order to estimate or observe what are the KPI and KVI, and then we can feedback for iteratively improving the 6G system design. Of course, during this process, we have to make some trade-off, as conformance to the key value of sustainability can lead to degraded performance. In the second sub-process, it's much related to having this alignment between the top-down approach, where we design the system, and the bottom-up approach, where each individual component are developed. And in brief, this conduct to perform some analysis to consider pros and cons of each enabler, and also conduct different analyses to evaluate compatibility, commonality, and so on. And as a first step of this alignment process, we have provided some set of criteria. And for example, when considering the development of an enabler, we want to check how it fits with the system design principle, how it impacts versus how it is feasible with the migration options that we recommended and shown at the beginning of this talk. Also, if there is some dependency with other enabler and so on. On those kind of criteria, we have looked at the first set of enabler developed inside the project, and they are related to aspects related to management and orchestration, and we map this first step of enabler on this system blueprint to come up with more refinement on this system blueprint perspective of management and orchestration. And also, we provided an early view of this management and orchestration by considering a framework based on intent for the end-to-end service management automation framework. Basically, inside this tool, we think that telecom service provider will not only provide the telecommunication services as traditional connectivity service, but indeed, it can become a digital service provider by providing additional services that are more application-centric service. and also offering, for example, AI as a service, compute offload, and so on. So this is why we've got this digital service provider role that is highlighted here, and that is interfacing with a wide set of application with customer. And also this digital service provider indeed will offer those services towards those customers by aggregating different set of capabilities. So this is why we have this capability operator here role to highlight that those capabilities can cover different domains. All of those domains can be, of course, autonomously managed, but they can also come from different providers. And the exposure towards customer will be via intent-based API, and also this intent-based API can be used at lower level to interact with different domain. And also something that is important to mention is that the service that will be provided could be indeed an aggregation coming from service exposed by our digital service provider, and via some aggregator, or also just because a digital service provider can also go into federation, so they can directly interact still with intent-based API to expose rich service set towards the customer. So just to finish, as I mentioned already, we've got this system proof of concept to validate that our system design, and also demonstrates that we can achieve some targeted KPI, and this system proof of concept will indeed have a gradual addition of the capabilities of the system by integrated some enabler coming from Hexa-X-II. Of course, we won't not be able to integrate all the enabler, but a selected set. And the first one will relate to management and orchestration, and then we will progressively add more enabler related to network architecture and transformation, including beyond communication, flexible topology. And then after that, also looking at enabler and component related to radio and 6G device. And I just want to mention that at this stage, we have already provided the system proof of concept number 1, with some preliminary result, and now we are working on this system POC B. And I won't detail the system POC, and I just want also to highlight that in order to complete the evaluation, we will conduct also some end-to-end simulation framework based on a kind of digital twin of in order to evaluate the connectivity enabler developed within Hexa-X-II. I will finish here, and just to indicate that if you want more detail, you've got these two deliverables that was provided by Work Package 2 on this foundation of the 6G system design. And this will conclude my talk.